at our lab, the vectors of Jupiter High School. So we're going to use a map of the school, and we're going to use a ruler and a protractor and look at vectors graphically. So it says the words distance and displacement refer to two very different quantities. If you leave home and walk a distance of 10 kilometers, you might end your walk 10 kilometers east of home, 5 kilometers east of home, or back at your home. Your final position or displacement depends not only on the distance you travel, but also the direction in which you walk. So displacement includes both the distance and the direction of change of position measured from the starting point. Therefore, displacement is a vector quantity and can be represented by an arrow-tipped line segment. The length of the arrow drawn represents the direction of the quantity. The vectors are added by placing the tail of one vector at the head of the other. So the resultant is drawn by connection of the tail of the first vector to the head of the second. Okay, so we're going to use a scale here. So the scale is 1 centimeter on the map is 15.5 meters in the school. So here is the map of the school, okay? And we're going to use this map to answer some of the questions. And we're going to be measuring as well. So question number 1 says, use the scale on the map, and this should be meters, to determine the distance in meters. So now we're looking at distance. So distance is, we're just going to measure where we go. So it says from the entrance of the school to the double doors in front of the atrium. So here I am at the front of the school, and here are the double doors in front of the atrium. So now what I'm going to do is I'm going to take my ruler, and I'm going to measure that. And it's a little bit less. Now remember that these numbers here, these are centimeters. So that's 1, 2, 3, 4, 5, 6. So it's obviously less. So it's about maybe 6.7 centimeters when I measure it. So now on my lab sheet, I'm going to say this is 6.7 centimeters. And now I'm going to use my scale here. So I'm going to take 6.7 centimeters. And I'm going to multiply it times 15.5. So that tells me in the school, the actual distance came out to be, it's at 103.85 meters, and we'll just approximate our final answer will be 104 meters. Now you're going to your first period class, Honors Physics with Ms. Plagman. You walk straight to the hallway in the middle of the atrium. You make a right and walk down the 4,000 hallway towards the 7,000 wing. You turn left and walk down to Ms. Plagman's classroom. What is the distance you traveled? Okay, so you ended up walking like this. And that was the first thing we measured. Now you end up going, and everyone's going to be a little bit different. So you try to go down to the middle of the hallway. Then you go here. And then you go like this. And there's the classroom. Okay. So now it says, what is the distance that you traveled? Okay. So we're talking about starting from here, not from the beginning of the school. So we're going to measure this, we're going to measure this, and we're going to measure this, and that's going to be our total distance. So we're going to again measure in centimeters. That's about 1.2. Then we're going to measure this way. That's about oops. 2.9, and then we measure this way, and that's about 3.6. Now I forgot what I said. So 1.2, I'm just going to write it on here, 1.2, and then 2.8, and then 3.6. So when it says, what is the distance? Remember, first I'm going to add them up. So I'm going to say 1.2, this is in centimeters, plus 2.8 centimeters, plus 3.6 centimeters. And when I add that all up, that comes out to be 7.6 centimeters. But now I'm going to convert it. So 7.6 times 15.5 is about 117.8, which we'll just say is 118 meters. So that's my distance. Then it says, what's my displacement? Now, remember, my displacement is from where I start to where I end up. So if I look at my map, I started here, and I ended up there. So I'm just going to draw a straight line connecting those 2 points. So that's my displacement. So I'm going to take the ruler, and I'm going to measure that. And it looks about to be 5.6. So my displacement is about 5.6 centimeters, and now with my conversion, 5.6 times 15.5 comes out to be 86.8 meters, which we're going to just round to 85 meters. Now it's time to go to your ACE class with Mr. Wober in Portable Ford. You walk out of the end of the 7000 wing and outside along the portables. What is the distance you traveled? Okay, so now, and we're just going from my room to Mr. Wober's room. Mr. Wober was in my class when he was in high school. All right, so now we start here. And I'll do this in a different color so we don't mix it up. And we go like this. And Mr. Wober's down there. And then we're going to go to here. And I won't count like walking in the door. So when we measure this, that's 1. So it's a little bit more than 1, like 1.2. And then we're going to measure this. And that looks about 10. So the distance is 1.2 centimeters plus 10 centimeters is 11.2 centimeters. Now I'm going to do my conversion. 11.2 times 15.5 comes out to be 173.6. So we'll say about 174 meters. What is your displacement? So the displacement, again, is going to be from where you start to where you end up. So now, when we look at it, this is where I start, this is where I end up. I draw a line, connecting, and that's my displacement. So when I measure my displacement, and I put it up and measure, that looks about 10.3. So 10.3 centimeters. And now I'm going to convert that to meters. So I'm going to say 10.3 times 15.5 is 159.65 meters. And we're going to say that's about 160 meters. All right, your third period class is English with Mrs. Katzman in room 5106. You walk out of portable 4 to the entrance and down the hall to her room. So again, what we're going to do is we're going to start off looking at the distance, then we're going to look at the displacement, and you can do these. Let's look at the back part of the lab. So the back part of the lab says, in the space below, use the same scale, and this should be meters. You walk 62 meters north, and then turn right and walk 31 meters to the right. So what you do is you pick a starting point. Now I'm going to go 62 north. Now remember, we're going to use the same scale that's on here. So if it's 62 meters, I'm going to say 62 divided by 15.5. So it's going to be 4 centimeters. So I'm going to start right here, put it on 4, and I'm going to go 4. Now your lab sheet is smaller, but this 4 centimeters represents 62 meters. From the head of this vector, I'm going to do the tail of the other. So if it's then 31 meters, it would be half of that, which would be 2 centimeters. So this 2 centimeters represents 31 meters. How did I get that? That's a 31. What I did was I said 31 divided by 15.5, and I got 2. From where I start to where I end up is my resultant. I'm going to go like this. This is where I started. That's where the tail goes. This is where I end up. That's where the head goes. And then there is my arrow. So now it says calculate your distance. So the distance is going to be 62 plus 31 is equal to 93. My displacement is from where I start to where I end up. Now, if I do this, see how it says calculate? So there's a difference between calculating and measuring. Calculate means I use math. Measure means I'm using it to scale. So now when it says calculate your displacement, this is a right triangle, and I want to find the hypotenuse. So what I'm going to do is I'm going to use the Pythagorean theorem, and I'm going to say 62 squared plus 31 squared, and then I'm going to do that on my calculator. 62 squared plus 31 squared equals square root 69.3 meters. So my final answer is 69.3 meters. I pressed all the buttons so fast I didn't write my intermediate value there. Now it says measure the angle of your resultant from the northern direction. So now I'm going to take my protractor and this is the northern direction. So I'm going to measure that angle. So what I'm going to do is I'm going to take my protractor. This line lines up here where the 90 should be. Too bad I don't have a smaller one. And now I'm going to measure this angle. So this is 10, 20. It looks about maybe 28 degrees. So with the protractor, that's what measure means. This is going to be 28 degrees, and this angle here is east of north. Now, if I measure this other angle, just draw a horizontal line there, I would take my protractor like this, and then I would measure the angle this way. So it would either be 28 degrees east of north, and then, or I could say 62 degrees north of east. Now it says calculate the angle of your displacement. So how am I going to calculate this angle? Well, I have opposite and I have adjacent, so I'll use tangent. So I'm going to say tan of theta, and this is what we've been doing the last 2 days. This is what we did yesterday. So tan of theta is opposite over adjacent. So tan of theta is 31 over 62. So now on my calculator, 31 divided by 62, I should be able to do that in my head, is half. And now I'm going to press second tan to give me the angle. So now I see that theta is equal to 27 degrees. So if you want to write some intermediate steps, you can say tan of theta is equal to 0.5, and then you solve for theta, and you get this. And then you're going to calculate your percent error. So calculate your percent error for your measured angle and your calculated angle. So remember that percent error is equal to your accepted value, which we're going to assume is the mathematical one, minus your measured value, divided by your accepted, and then times 100%, because that should be in the form of a percent, because when I do this, I'll probably get a decimal. And that's it. So we did most of this together, and you just have to finish up the rest. And again, this is just practicing and understanding that we can do things both mathematically and graphically. So using our ruler and protractor, we can see how to find the length. And if I wanted to measure this, so remember, this displacement, I could see, oh, is this about what it should be? So it says 69.3, so maybe 7 centimeters. I might not have drawn it perfect. Oh, that's a displacement. Well, this came out to, this is 69.3. That's according to our scale. So if I measure it, it comes out to be about, what, 4.1 or 4.2. And then I multiply that times 15.5. So I said 4.2. It could have been, it's hard to see this. Oh, it's way more than that. I mean, it's like 4.6. So you could, by using your scale, check your work, both graphically and mathematically. And that's the lab. So you just have a little bit more that you have to finish on your own.